Hello and welcome to Food Safety Fridays. My name is Simon Timpley from the International Food Safety and Quality Network, and today's special guest presenter is our good friend Tony Connor. Good day,
Hi,
Tony.
Everybody. Hi, Simon. Hi, everyone.
How are you doing today, Tony?
Oh, not too bad, thanks. Not too bad.
Raring to go.
That's it, yeah.
The topic today, establishing GMPs in compliance with GFSI benchmark standards. So we'll have start the presentation shortly, but first, tell us where you're joining us from in the sidebar. It's always good to know. And going past two quickly, but everywhere there: Holland, Missouri, UAE, Milwaukee, all sorts of wonderful places. So I hope you are all happy, healthy, and comfortable. I'm going to play the sponsors ads now, a couple of minutes, and we'll be back for the presentation.
The world of food has changed a lot in the last 100 years. But one thing that doesn't change? Ensuring the quality and safe handling of food. No matter what changes are yet to come, we're proud to always be on our clients' side, shaping the future of food, today and tomorrow. AIB International, ever onward.
Okay, ready now with the slides. I'll be back for the Q&A after Tony's presentation, but for now I'll leave you in the hands of Tony.
Thank you, Simon. Okay. So today's webinar is on good manufacturing practices. Food business operators should control food safety hazards through the use of systems such as HACCP. Codex recommended general principles of food hygiene. These systems should be used to control food hygiene. A model of such system is described in these general principles, and also hazard analysis and critical control point system and guidelines for its application, which is in the annex. Prior to conducting hazard analysis, though, it's essential to ensure that good manufacturing practices are in place. Good manufacturing practices are practices required in order to conform with the guidelines recommended by agencies that control the authorization and licensing of manufacture and sale of food and beverages, etc. These guidelines provide minimum requirements that a manufacturer must meet to assure their products are consistently high in quality from batch to batch for their intended use. Good manufacturing practices create base conditions for the hygienic production and handling of food. They're put in place to control general hazards. If good manufacturing practices are not functioning effectively, then the introduction of HACCP will be complicated, resulting in a cumbersome, over-documented system. Prerequisite programs such as good agricultural practice, good manufacturing practice, good storage practice, good distribution practice, good hygienic practice must be working effectively within the system before HACCP is applied. Good manufacturing practices assist in controlling or preventing the introduction of food safety hazards through the work environment, eliminate, prevent, or reduce to an acceptable level the contamination of products, including cross-contamination between products, to control and/or prevent food safety hazard levels in the finished product, ingredients, and product processing environment. So, what good manufacturing practices are recommended to prevent the contamination of food products? There should be environmental controls, construction and layout of buildings and utilities, layout of premises, including workspace and employee facilities, supplies of air, water, energy, and other utilities, supporting services, including waste and sewage disposal, the suitability of equipment, management of purchased materials, measures for the prevention of contamination and cross-contamination, cleaning and sanitizing, pest control, personal hygiene, control of rework, product recall procedures, warehousing, product information and consumer awareness, food defense, training and supervision. So let's go through those. Environmental controls. Potential sources of contamination need to be considered when deciding where to locate food establishments. Also, in conjunction with the effectiveness of any measures that might be taken to protect foods. Establishments should not be located where, after considering such protective measures, it is clear that there will remain a threat to food safety. Establishments should be located away from environmentally polluted areas and industrial activities which pose a threat of contaminating food, areas that are subject to flooding, areas prone to pests, areas where waste cannot effectively be removed. Construction and layout of buildings, workspace, and utilities. The fabric of the site, buildings, and facilities should be applicable. Internal structures should be soundly built of durable materials and easy to maintain, clean, and where appropriate, be disinfected. The surfaces of walls, partitions, and floors should be made of impervious materials with no toxic effect. Walls and partitions should have a smooth surface. Floors should be constructed to allow adequate drainage and cleaning. Ceilings and overhead fixtures should be constructed and finished to minimize the buildup of dirt, condensation, and the shedding of particles. Windows should be easy to clean, protected such that they do not present a contamination risk, be constructed to minimize the buildup of dirt, and where necessary be fitted with insect-proof screens. Doors should have smooth, non-absorbent surfaces and be easy to clean. Working surfaces that come into direct contact with food should be in sound condition, durable, easy to collectance. The flow of product, personnel, services, and materials should be such that they significantly reduce the risk of product contamination. Personal hygiene facilities should be available to ensure an appropriate degree of personal hygiene can be maintained and to avoid contaminating food. There should be staff facilities for changing, storage of personal items, segregation of personal items from work clothing, hand washing, toilets, smoking areas, if permitted, eating and drinking. Layout of premises. Where appropriate, the internal design and layout of food establishments should permit good food hygiene practices, including the protection against cross-contamination between and during operations. This particularly applies to high care and high risk food facilities, where there needs to be segregation of high risk foods from contamination. Separate changing facilities may need to be provided for personnel working in high risk and high care areas. Supplies of air, water, energy, and other utilities. Water, ice, air, and other gases need to be controlled and monitored. So you need to monitor the water supply, the distribution of water, and any gases and steam that is used. An adequate supply of potable water with appropriate facilities for its storage, distribution, and temperature control should be available. Potable water should be specified as per the latest edition of the World Health Organization Guidelines for Drinking Water, or water of a higher standard. Non-portable water, for example, that's used in fire control, should have a separate system. Non-potable water systems should be identified and not connect or are allowed to reflux into potable water systems. Only potable water should be used in food handling and processing. There may be exceptions, such as for steam production, fire control, the use of clean seawater. Water recirculated for reuse should be treated and maintained in a condition such that there is no risk to the safety of food. The treatment process should be effectively monitored. When water is used as an ingredient, potable water should be used. Ice made from water should be made from potable water. Ice and steam should be produced, handled, and stored to protect them from contamination. Ventilation. Adequate means of natural or mechanical ventilation should be provided, in particular to minimize airborne contamination, such as from aerosols and condensation. Ventilation systems should be designed and constructed so that air does not flow from contaminated areas to clean areas, and systems, where necessary, should be able to be maintained and cleaned. Lighting. Adequate natural or artificial lighting should be provided to enable the undertaking of operations in a hygienic manner. The intensity should be adequate to the nature of the operation. A minimum of 200 lux is typical for operations and 500 lux for inspections. Lighting fixtures should, where appropriate, be protected to ensure that food is not contaminated by breakages. Waste control. Adequate drainage and waste disposal systems and facilities should be provided. Systems should be designed and constructed so the risk of contaminating food or the potable water supply is avoided. Systems should be in place to minimize the accumulation of waste, including arrangements to control the collection, collation, and disposal of waste material. Waste disposal should be managed in accordance with legislative requirements. You need to consider controls for licensing and legislation, for storage of waste, for unsafe and trademark waste. Waste should not be allowed to accumulate in food handling, food storage, and other food working areas and the adjoining environment. So, waste is likely to be contaminated and should not be allowed to accumulate. Food handlers should wash their hands after handling waste. Lids should be kept closed on waste containers as waste attracts pests. Provisions should be made for the removal and storage of waste, and waste stores should be kept appropriately clean. Containers for waste, byproducts, and inedible or dangerous substances should be specifically identifiable in suitably constructed containers made of impervious materials. Containers to hold dangerous substances should be identified and be lockable to prevent malicious or accidental contamination of food. Waste disposal systems should ensure the risk of contamination of products is minimized. There should be the systems for the management of surplus foods and products for animal feed. Equipment. Equipment should be hygienically designed and constructed. Where appropriate, there should be racks or areas for the storage of equipment, including food contact equipment. Equipment should be located so it permits adequate cleaning and maintenance, functions as intended, and facilitates good hygienic practices. Good design and effective hygiene standards are required to ensure equipment poses no threat to food. Equipment and containers coming into contact with food should be designed and constructed to ensure that where necessary they can be adequately cleaned, disinfected, and maintained to avoid the contamination of food. Equipment used to cook, heat, treat, cool, store or freeze food should be designed to achieve the required temperatures as rapidly as necessary in the interests of food safety. Equipment should also be designed to allow temperatures to be monitored and controlled. These requirements are intended to ensure that harmful or undesirable microorganisms and their toxins are eliminated or reduced to safe levels. Where appropriate, critical limits established in HACCP-based plans can be monitored, and that temperatures and other conditions necessary to ensure food safety and suitability can be rapidly achieved. Moving on to management of purchased materials. There should be a documented risk assessment of each raw material or group of raw materials, including primary packaging, to identify potential risks to product safety, legality, and quality. Consideration should be given to the significance of the raw material to the quality of the final product. The risk assessment should form the basis of raw material acceptance and testing procedures and the process adopted for supplier approval and monitoring. Certification to a GFSI benchmark standard may be a prerequisite for supplier approval. If so, you should confirm the validity of the certification. The company should also ensure that its suppliers have an effective traceability system. For certification, you will need to confirm the certification, confirm that the certification is up to date, and ensuring that the materials are within the scope of the certification. Alternatively, supplier approval may be by a site audit which covers at a minimum product safety, traceability as I've mentioned, HACCP, and good manufacturing practices or processes. These audits must be completed by an appropriately experienced and trained auditor. When this auditor is a second or third party, you would need to be able to demonstrate the competency of the auditor, confirm the scope of the auditor, and obtain and review a copy of the full audit report. For low-risk suppliers, sometimes a completed supplier questionnaire may be used for approval. There should be a process of ongoing review and monitoring of suppliers. This should be based on risk and using defined performance criteria. No raw material or ingredient should be accepted by an establishment if it is known to contain parasites, undesirable microorganisms, pesticides, veterinary drugs or toxins, decomposed or extraneous substances, which could not be reduced to an acceptable level by normal sorting or processing. Where necessary, specifications for raw materials should be identified and applied. Raw materials and ingredients should be inspected and sorted before processing, if appropriate. Where necessary, laboratory tests should be made to establish the fitness for use. Only sound, suitable raw materials should be used. Stocks of raw materials and ingredients should be subject to effective rotation. There should also be systems, where appropriate, for the approval of monitoring of suppliers of services and outsourced processors Food fraud. A vulnerability assessment should be carried out by a food fraud team to assess the potential of risk of food fraud. The scope of the assessment should include counterfeiting, stolen goods, dilution, substitution, concealment, unapproved enhancements, mislabeling, misbranding, or diversion. Where materials are identified as being at a particular risk of adulteration or substitution, the control plan should include appropriate assurance and/or testing to be put in place to reduce the risk. For example, testing when there are known risks such as red meat substitution, fish substitution, protein substitution such as melamine in milk powder. Other foods considered high risk of substitution include fruit juices, olive oil, spices, coffee, honey, maple syrup, tea, organic foods, grains, and wine. Packaging. Packaging design and materials should provide adequate protection for products to minimize contamination, prevent damage, and accommodate proper labeling. Packaging materials, where used, should be non-toxic and not pose a threat of the safety and suitability of food under the specified conditions of storage and use, such as microwaving or cooking in the container. Where appropriate, reusable packaging should be suitable, durable, easy to clean, and where necessary, disinfect. Specifications. Management systems described in control of foods hazards should offer an effective way of ensuring the safety and suitability of food. Where microbiological, chemical, or physical specifications are used, such specifications should be based on sound scientific principles and state, where appropriate, monitoring procedures, analytical methods, and action limits. Moving on, measures to prevent contamination. Systems should be in place to prevent contamination of food by foreign bodies such as glass, metal shards from machinery, dust, harmful fumes, and unwanted chemicals. Appropriate facilities and procedures should be in place to control the risk of chemical or physical contamination of product. Physical contamination. Foreign objects cause illness, distress, adverse publicity, loss of business, and fines. Procedures should ensure that no foreign matter gets into food products, and constant vigilance of employees by following the rules and reporting risks can eliminate unwanted items. In manufacturing and processing, suitable detection or screening devices should be used where necessary. Glass in food can cause serious injuries. Glass items should be prohibited unless absolutely necessary. When used, they should be checked regularly and any breakage reported immediately. Control of glass, brittle plastic, ceramics, and similar materials. There should be exclusion of unnecessary materials or protection, documented handling procedures, a register of brittle materials, checks of brittle materials, breakage procedures, protection of windows and lighting against breakage. Critical items may need to be checked at the start and end of each shift. Key documents required include a list of items giving details of their location, number, type, and condition, a risk assessment defining the frequency of required checks, records of routine inspections, procedures to allow cleaning or replacement of items, and a procedure for management of any breakages. Based on risk assessment, procedures shall be implemented to minimize foreign body contamination originating from the packaging container. This may include the use of covered conveyors, container inversion, or foreign body removal through rinsing with air or water jets. Metal control. Sharp metal implements need to be controlled. Snap-off blades should not be used. There should be a control of stationary items such as staples, paper clips, etc. The risk of product contamination should be reduced or eliminated by the effective use of equipment to remove or detect foreign bodies. The hazard analysis should be a starting point for implementing effective foreign body control program. Potential hazards and the sources of these hazards should be identified so that appropriate control measures can be put in place to minimize the likelihood of product contamination. Ideally, metal detection equipment should be in place unless risk assessment demonstrates that this does not improve the protection of final products from metal contamination. Other physical contaminants procedures need to be in place to prevent physical contamination of raw materials by raw material packaging, such as when debagging or deboxing. Pens in open product areas should ideally be metal detectable and colored and controlled. Wood should not be used in open product areas except where there is a process requirement. Chemical controls. Chemicals should be securely stored away from food and packaging. Food handlers need to be alert to the possibility of chemical contamination in the form of cleaning chemicals and pesticides, etc. There should be instructions for the use and storage of chemicals which should be followed. There should be controls of the storing and handling of non-food chemicals and strong chemicals with strong taints and scents. Maintenance. Establishments and equipment should be kept in an appropriate state of repair and condition. Maintenance work should be carried out outside of production hours. Maintenance controls should include a maintenance schedule, equipment inspection, control of temporary repairs, a clean-up after maintenance work, equipment inspection by an authorized member of staff. That's after maintenance work. Materials and parts should be of an appropriate grade or quality. Where there is a risk, maintenance chemicals such as lubricants should be food grade. Operational controls. There should be documented procedures and work instructions that ensure the production of a consistently safe and legal product. There should be manufacturing instructions and process specifications, specified equipment settings. There should be process monitoring, and there should be controls in the event of an equipment failure. Where equipment settings are critical to the safety or legality of products, changes to those settings should only be done by trained and authorized staff. Inadequate food temperature is one of the most common causes of foodborne illness or spoilage. Controls include time and temperature settings such as cooking, cooling, processing, and storage. Systems should be in place to ensure that temperature is effectively controlled, where it is critical to the safety and suitability of food. Temperature control system shall take into account the nature of the food, its intended shelf life, method of packaging, how the product is intended to be used. Systems should specify tolerable limits for time and temperature variations. Temperature recording devices should be checked at regular intervals for accuracy. Other steps which contribute to food safety include other thermal processing, irradiation, drying, chemical preservation, vacuum or modified atmosphere packing. Inadequate allergen segregation is a common cause of foodborne illness. Controls include the separation of allergens, the areas and people handling them. Typically, it's a fundamental requirement for a system to be in place for the management of allergenic materials, and this system minimizes the risk of allergen contamination of products and meets legal requirements for labeling in the country of manufacture and sale. There should be controls of raw material, which should be assessed. There should be a list of allergenic materials. There should be risk assessments for cross-contamination. There should be cross-contamination prevention procedures, control of rework. There should be unpacked warning labels. And there may be allergen cleaning regimes. Traceability. There should be a documented traceability procedure designed to maintain traceability throughout the site's processes. Identification of raw materials, intermediate products, finished products should be adequate to ensure traceability. The site should test the traceability system across the range of product groups to ensure traceability can be determined from the supplier of raw material, including primary packaging, to the finished product. This should include a quantity check or mass balance. Inadequate raw and cooked food segregation is one of the most common sources of foodborne illness as well. Pathogens can be transferred from one food to another either by direct contact or by food handlers. Systems should be in place to ensure that rework is controlled. Where rework of products is undertaken, consider whether this will affect the product, i.e., whether the ingredient declaration will need to be changed. Ideally, products should be reworked on a like-for-like basis. Cleaning and sanitizing. Adequate facilities suitably designated should be provided for cleaning of food, utensils and equipment. Such facilities should have an adequate supply of hot and cold water. Cleaning should remove food residues and dirt which may be a source of contamination. Cleaning and disinfection programs should ensure that all parts of the establishment are appropriately clean. Cleaning programs should specify areas, items, equipment and utensils to be cleaned, responsibility for the tasks, method of cleaning, and monitoring arrangements. I like to include photos in my cleaning procedures. As you can see here, this is an example. It's important that all of the parts of the factory are kept clean and free from contamination. That's even more critical for food contact surfaces. So what's the function of cleaning? It removes dirt, debris, food residues, reduces bacterial levels, allows disinfection. Disinfectants are chemicals that destroy microorganisms. Sterilization. Surfaces and equipment are sterilized with heat after normal cleaning. So, we clean to reduce the risk of bacterial contamination, reduce the risk of food poisoning and storage, and reduce and eliminate problems with pests. Floors, ceilings, walls, drains, pipes, and all other surfaces should be kept in a clean, hygienic condition. Sanitation systems should be monitored for effectiveness. The use of ATP swabbing is now an effective method of monitoring cleaning effectiveness and should be considered where the standard of sanitation is critical to food safety, such as on food contact surfaces and in high care facilities. Limits of acceptable and unacceptable cleaning performance should be defined for food contact surfaces and process equipment. Environmental monitoring. The use of monitoring techniques within the factory is an important tool for identifying risk of potential product contamination with both pathogens and spoilage organisms. There should be a priority order for sampling from food contact surfaces to other areas such as hand wash sinks, floors, walls, drains. The environmental monitoring should, as a minimum, include open product areas and areas where ready-to-eat products are handled. Here's a weekly, monthly, and quarterly schedule for surfaces, including specified tests, TVC, yeast and mold, entro, and pathogens. Pest control. Common pests include rats, mice, cockroaches, flying insects, and birds. As well as carrying bacteria, rodents can gnaw their way into materials and cause substantial damage. So it's important to prevent access to pests, such as proofing loading docks. Similarly, adequate measures should be put in place to prevent birds from entering buildings and also from roosting. Pests are a major threat to food safety. Pest infestations can occur where there are breeding sites and a supply of foods. Good hygienic practices should be used. Buildings should be kept in good repair and condition to prevent pest access. The availability of food and water encourages pest harborage and infestation. Potential food sources should be protected and stored. Establishments and surrounding areas should be regularly examined by a competent person for evidence of infestation. Any infestation should be dealt with immediately and without adversely affecting food safety. Treatment with chemical, physical, biological agents should be carried out without posing a threat to the safety of food. Pesticides should not be used in food handling areas. Prevention of contamination, personal hygiene. Personal hygiene standards should be developed to minimize the risk of product contamination from personnel. There should be documented personal hygiene policy, including controls for hand washing, cuts and grazes, first aid, metal detectable plasters, medicines. Medical screening should be in place. Illness should be reported to management. Protective clothing should be provided to employees to work on entering food areas. Protective clothing needs to be controlled so that it isn't a contamination risk. Let's look at a typical hygiene policy. The company should have a documented hygiene policy proportionate to the risk to the product that is followed at all times. Before entering any part of production area, personnel, including visitors and agency staff, should wear suitable, clean, protective clothing. Any company issued protective clothing shouldn't be taken off site. You don't want people playing with their dogs or pets with the clothes they work in. Clean headwear to enclose hair and ears should be worn. Visitors and outside personnel should have permission to enter product areas. Approved visitors should be supplied with protective clothing. Cigarettes, tobacco, lighters, and loose items should not be carried in the pockets of clothing when in product areas. Nail varnish, false nails, eyelashes, and hair grips should not be permitted. The use of cosmetics such as perfume, lipstick, and aftershave should not be permitted. Jewelry can fall into food, get caught in machinery, and harbour bacteria. With the exception of plain band ring, no jewelry, including watches, should be permitted. Eating and drinking should only be permitted in a designated area. Eating, smoking, and drinking transfer bacteria from mouth to hands, which could then contaminate the food. Hand washing facilities should be provided at entrances to product areas. It's best practice to use an antibacterial soap. Smoking should be prohibited in all product areas. Spitting should be forbidden anywhere on site. First aid, there should be control of drugs and medicines, which should be prohibited from all food handling and processing areas. Cuts, grazes, scratches, and boils can contain germs and should be covered with a waterproof coloured dressing. Only authorised personnel should enter the laboratory or engineering workshop. Infected food handlers can contaminate food, and so should be prevented from working until they've had medical clearance. Personnel should report any illness, but particularly sickness or diarrhea. Food handlers should always wash their hands after they've been to the toilet. Touching cooked food should be avoided. Clean utensils should be used. Just getting back to some operational controls. We've mentioned rework. Any rework operation should be included in the product flow diagram, and there should be specific documented procedures to control rework. Recall procedures. Managers should ensure effective procedures are in place to deal with any food safety hazard and to rapidly recall any implicated lot of finished product. The need for public warnings may need to be considered. Recalled products should be held until supervision until a decision has been made. Storage and temperature control. Storage facilities should be suitable for purpose. There should be procedures to maintain product safety and quality during storage on the basis of risk assessment. Storage facilities should be adequately designed and constructed. Food facilities should be designed and constructed to permit adequate maintenance and cleaning, avoid pest access and harbourage, enable the food to be effectively protected, and provide an environment which minimises the deterioration of food. Where necessary, there should be separate, secure storage facilities for cleaning materials and hazardous substances. Temperature control. Cold food should be 41 degrees Fahrenheit and below. Frozen food should be below -18 degrees centigrade. So, food storage facilities should be designed and operated to prevent contamination. Products, packaging, and materials should never be stored directly on the floor. Procedures should be in place to ensure that the management of dispatch and of the vehicles and containers used for transporting product do not present a risk to food safety. During transport, measures should be taken to protect food from potential sources of contamination. Conveyances and containers should be designed so that they do not contaminate packaging. All foods can be effectively cleaned and permit effective separation and protection from contamination such as from dust and fumes. Conveyances and containers for transfooding food should be kept in an appropriate state, and where appropriate should be marked for food use only and be used for that purpose only. Product information. Products should bear appropriate information to ensure adequate information is available to the next person in the food chain or to the consumer. Inadequate product information can lead to products being mishandled by consumers or later in the food chain. It's important that foods are labelled with clear instructions to enable the next person in the food chain to handle, display, store and use the product safely. Prepackaged food should be labelled with clear instructions, including storage and use instructions. Product labelling should comply with appropriate legal requirements and contain sufficient information for consumers and customers to use the product safely. There should be label reviews to review the legality of labels, nutritional claims, and any cooking instructions. Where cooking instructions are provided, they should be fully validated. Labeling activities should ensure that products will be correctly labeled and coded. This is an example of a label check and retention record. The label is cross-checked by 2 operators in real time, cross-checked by the supervisor hourly, and signed by and checked by the production manager at the end of the shift. Changes in labels should be communicated to goods receipt staff. There should be procedures to manage obsolete packaging. There should be control of offline coding and printing, and all relevant staff should receive training on labeling and packing processes. Food defense. There is a need for a documented threat assessment and subsequent food defense plans. Training and supervision are important elements in maintaining food safety. Employees need to understand their responsibilities and should be adequately supervised. Periodic assessments of the effectiveness of training and instructions programs should be made. There should be routine supervision and checks to ensure that procedures are being carried out effectively. The company should ensure that all personnel performing work that affects product safety, legality, and quality are demonstrated to be competent to carry out their activity through training, work experience, and qualification. There are specific requirements for initial training and supervision, CCP training, allergen training, training on sites, labeling and packing processing. There should be a documented training program, training records, and competency review. So summarizing, adherence to company good practices such as good manufacturing practices is essential. They set out general hygiene standards that should be achieved. When selecting or establishing these, the food safety team will need to consider appropriate information. The prerequisite programs will need to be appropriate to the operation and proportionate to the product risk. When conducting your hazards analysis, you may identify programs to control specific hazards. There should be appropriate records of processing, production, and distribution that are retained for periods that exceed the shelf life of the product. Documentation to verify proper implementation of prerequisite programs and good manufacturing practices. Records should be demonstrated from these and demonstrate they are implemented and working effectively. These records should be monitored by authorized personnel. Okay, there's quite a lot to get in there. Any questions? Anybody?
Hundreds.
Okay.
Yeah, it's always best to leave your questions till the end because they've just all disappeared now.
Oh, right.
So we'll take questions from now.
Sorry about that. Yeah.
Have you got if you switch your webcam off, Tony? There was some connection issues for some people early on, but it was fine with me here. So I'm guessing there's some turbulence in the servers across the world with weather and things like that. So, but the recording will be fine. So don't worry, everybody. So, okay. So you'll all get a copy of the PDF of the PowerPoint afterwards and the recording as well. So any questions now? So yeah, so Vinod, what's Vinod saying? Whether frequent GMP and hygiene audit is required to ensure the appropriate implementation.
Yeah, I didn't mention GMP audits, but GMP audits and inspections, as the GFSI benchmark standards sort of refer to them as, are very important, and they can be used as a verification tool that a lot of these things we've talked about, you can go around and check them, and we, routinely in high-risk areas should be open product areas, minimum of monthly, probably more frequent. You might want to have startup checks for some of the things, such as if you've got glass or a glass dial and something in an open food area. Yeah. Okay. So, yeah.
Okay, thanks, Tony. Javier, what are your thoughts on using ATP plus ADP plus AMP test versus a conventional ATP test to determine the validity of a sanitation program?
I think all my experience is based on individual sites and surfaces. So I think they work. I think it's it's trial and error, really.
Okay, Albert, can our presenter, Tony, emphasize the glass breakage monitoring process?
Okay, so you've got glass items, you decide how much risk is associated. You've got something on a filling machine that's a glass dial, that's very high risk. If you've got something, a clock over the door, that's medium and less risk. And if you've got something in the canteen, a clock in the canteen, that's low risk. So your high risk items you might need to do at the start and end of every shift to make sure it's okay. The clock, you might say, okay, I'm going to do, it's difficult for it to get in the product, so I might do that monthly, and I might do the canteen one every 6 months. So based on risk. Yeah.
Okay.
Thank you. And if you have a breakage, you stop, clean the whole area, isolate the product, quarantine it. Almost certainly you want to dispose of it, and that needs to be controlled. You clean up with glass, dedicated equipment to clean up the glass. That equipment is bagged and isolated. The debris is isolated and controlled. So yeah, okay.
Okay, Sylvia, some plants use control point or PRP after ISO 22000 to control some GMP. Yeah. What's your opinion?
I can see some GMPs we're talking can be very important. So you might have, it's an OPRP, operational prerequisite program. So you might have something like filtration, which removes foreign bodies. You might have something like allergen cross-contamination control, so cleaning and ELISA or allergen swabs on changeover from an allergen product to a non-allergen product. So yeah, there might be some critical control points identified, say as pasteurization, but there are others that might be OPRPs that you want to validate. Yeah,
Right.
and some of them might be GMPs, yes.
Okay, Julius, what are the testing parameters for air, not compressed air, that is used to cool products aside from micro? Can we use the same parameters that we use for compressed air?
Compressed air, yeah, it should be a similar standard, yeah. You're on about filtration. But if it's open, I don't know if it's sealed products, then it's less of an issue. If it's an open product that's likely to get dust or particle contamination, that's more of a worry. And also, obviously, the main worry might be micro that you're saying aside from that. Yes, I would think so. If you're talking about compressed air for contact in food. Yeah.
Okay. Jignesh, is the vulnerability study only for external providers?
I guess there could be some internal. There could be a possibility internally for substitution, but that might be covered by your food defence. So, preventing somebody from stealing labels or substituting ingredients on site, it'd probably be covered by food defence.
Vinod's asking whether pet animals are considered as pests in food facilities. Well, I'll answer that. There shouldn't be pets in a food facility of any shape or form. Sylvia, are Codex working on updating the hygiene food code or only the HACCP section? Are you aware of that? So,
I think they were looking at both.
All right.
It was supposed to be out a while ago, but I haven't kept up to date in the last few months, so I'm not sure where we are with that.
Okay. John Paul just would like to clarify if rework is required in the process flow diagrams, such as reinspection of whole products.
Reinspection isn't quite the same as rework. Rework is where something's repacked or relabeled, or yeah, I don't think it's quite the same. But reinspection it's not reworking.
Yeah, but should rework be on the process flow diagram? I think his question was.
Rework, it should be in the flow diagram, yes. Reinspection of whole products, that should be in your whole procedure.
Okay.
Control of non-conforming product, yeah.
Yeah, Brad. Does it must be just Brad. Does a packaging company have to have GFSI certification to produce direct food contact packaging?
Yeah. I mean, if I was buying from a packaging company for food contact, I would either insist on GFSI benchmark certification, or I'd come and audit you yourself, and you wouldn't like that, so you'd probably go for the GFSI certification.
There's nothing stopping you producing direct food contact packaging without GFSI certification, but you just might not having many customers.
Yep, exactly.
And decreasing further and further as time goes by. Nicole, are there specific pH requirements for municipal water sources?
There might be, but I think there are local requirements for water, so it might vary.
Okay.
Yeah, so I think it might vary from region to region and country to country.
Okay, Vinod, which technology will be helpful to detect bones in meat-based products? Any idea?
Probably X-ray. would be the best. I
Yeah.
would think. The bones are definitely more dense than meat, so I think X-ray is probably the best. But the problem with meat is you get grinding and stuff, and so metal contamination is a risk there as well. And metal detectors are probably better than X-rays for metal, so I don't know. You'd have to have a look, but definitely X-ray, which could pick up the metal as well in theory. Yeah.
Okay. Have you any experience of getting rid of birds in a big warehouse?
Well, I mentioned the roosting thing. The netting, the picture. There's some picture. A lot of stuff I talk about. I try and put up examples. There's netting on that loading area, which is preventing birds from roosting. So things for that. Catch them, get them out, and try not to let them back in again. But for birds, mainly it's roosting areas. So trying to lock those off, and netting is quite an effective way to do that, and spikes on buildings, that sort of thing.
Okay. Can you please talk more about knife control for operations?
Okay. Well, if this is in open product areas, then you should issue knives. Any breakages should be reported, and there should be a cleanup, and there should be an inspection and check by an authorized person, such as the supervisor. You shouldn't use snap-off blades. The knife should be on a register and regularly inspected.
Okay.
They should be food grade, not something that's going to snap quite easily either. Yeah.
Okay, good. Vinod, how can we ensure the jewellery policy implementation is relevant to culture-based beliefs, e.g. marriage, bracelets?
I think it's down to the risk associated with the product. If you're an open product and there's a risk of these falling in, then it should be cut quite clear when you're employed what the company policy is. So your employment contract will say, this is the standard. If you can't adhere to it, then don't work here.
Yeah. And Justina just asking, should hard plastics be included on the register, just like glass when broken?
Yeah. It's brittle materials, glass, brittle material, ceramics, if applicable. Anything that's brittle.
Yeah. So, can we do pest control internally? Is that sufficient?
You can, if you've got somebody that's competent, and you can demonstrate they're adequately trained and knowledgeable in pest control and in pest treatment and handling of pesticides.
Okay, Christine, how does GMPs apply to the food service sector?
Similar sort of things. There's a bit more on hygiene and vehicles of cross-contamination, things like hands, chopping boards, cloths. More of temperature controls, more of control of products, reheating, labeling of things in storage, because there's a lot more ingredients and items, fruit, vegetables, etc. And keeping control of those is a big job.
Okay. Yeah. What about for import export where there's sealed products? It's not opened. Does GMP, GHP, good hygiene apply, or what main elements apply?
Something sealed, but it's still in packaging, so it's okay for rats to crawl all over your consignment. Is that okay? My question would be. Of course, there's still, and also you want to have, even if it's sealed, if it's next to something that's highly tainting, such as a chlorophenol, hazardous chemical or chlorophenols next to a food product, then that's a problem. So it's not just hygiene and pests, which can contaminate outer packaging, and when then you open the outer packaging, you contaminate the product. But also it's possible for taints, etc.
Ryan's asking, do we need to monitor compressed air gases like for pneumatics that are not in contact with food?
I would say only if they're in like high risk areas and there might be air escaping in there, but not necessarily just to power a pneumatic. It's more so in contact with food, but I would say if your compressed air is escaping in a high risk or high care food area, then you don't want to be releasing dirty compressed air there.
Yeah, sure.
Yeah.
Patrick, how accurate is plate exposure method when checking compressed air quality micro when you don't have an air sampler? Is that
I think if you haven't got an air sampler, then that's what I would do. Yeah, an exposure plate. Bit difficult to measure. I guess you might do quite a few seconds or something of putting it across the plate, but it's better than nothing, Patrick. But obviously not as ideal or accurate, because an air quality sampler will take a measured amount of air across the plate.
Yeah. So, Tony, I've got a bald head. Imagine, do I have to wear a hairnet?
If you've got a bald head,
completely bald, not like a snooker ball, basically polished.
Yeah. I would. There isn't any logical reason, but I would that you should wear a hairnet if you've got no hair whatsoever. But I would say that it's company policy that people wear hairnets, and I'm not going to make an exception for you because you're unfortunate to have lost all your hair.
Yeah, because then it gets like, oh, well, you've got 1 millimeter of hair, you've got 2 millimeters of hair, and some people have. Is there another reason, dandruff or eczema and things like that possible?
Well, I could see, but I mean, there could be, but I mean, you can get flaky skin.
Yeah.
All over the body. So how much protection are you going to do? There isn't. If you're bald completely and have absolutely no hair, then there isn't a logical reason other than it's a standard that you apply to everybody. And I like to be consistent. So
So why don't we all have to wear beard snoots then?
Some of us haven't got much growth, I guess. Yeah, I think people have, the policy usually is, let's say a few millimeters. I know I've seen some policies that say a few days growth, and this has taken me 50 years, so a few days growth might be a bit less. So it's difficult to judge, but usually it's like, let's say a few millimeters or something like that. Yeah.
Yeah.
A bit embarrassing if you're asking the women to wear beard snoods, though. I find
that's true.
Without apologies if that's a sexist remark, but yeah.
Mukesh, what should be verified if any of GMP practice affected due to COVID, like external pest control? So basically. Pest control and laundry are affected by coronavirus, so you can't get them in, etc. So, what's the implications?
I think I'd still be trying to get them in, but maybe less frequently. Laundry. I don't see why that would be a problem. Normally, it goes off site, so you might still. Change your protective clothing, but maybe review the frequency.
Yeah.
So you still want to do these things, but maybe be more tolerant on frequency, and maybe do your own internal checks to substitute. So instead of somebody coming monthly, somebody coming every 2 months, and you do the one in between.
Yeah. Okay. Clifford's just saying bird repellent gel works well for us. Tina, if you have SQF certification, do we need GFSI certification? SQF is
GFSI GFSI don't certify. SQF is a benchmark standard, and it's benchmarked by GFSI. Okay. Yeah.
So yeah, LOISOS is internal validation of measuring equipment against the calibrated equipment allowed on CCP monitoring equipment. So internal validation of measuring equipment against the calibrated equipment, is that allowed on CCP monitoring equipment?
Providing you've got, I think it's, what is it? It's like a UCAS. It's an accreditation body certification for the equipment you're using to check your equipment with. So whatever you're testing it with needs to be have a certificate from an accredited laboratory.
Okay. Yeah. I think we're 15 minutes over, and we're not going to stop here. So I think we'll have to call it a day. I think one day we should just have a webinar where it's just questions. Ask Tony, and you spend an hour asking you any question and see if you fail at any. Probably not. Yeah,
well, okay. That'll be another nerve-wracking experience for me then.
Oh, no problem. Anyway, thanks very much, Tony. A couple of people asked where all those documents were from, but they're from the. Do you want to explain where those documents are from?
A lot of this presentation will be part of the practical HACCP training. So it's about a fifth of the practical HACCP training that we do, which is a 4-hour webinar. So but the documents. The documents are from IFSQN implementation packages, which we've got for all the major GFSI benchmark standards. So BRC, SQF, FSC 22000. Most of the documents are from those packages, which are sold on the IFSQN website.
Yeah, and they fully editable. All of those documents are unlocked. So if you want to have a look, that was just a small portion of the documents that are contained in some of those packages. So anyway, thanks very much, Tony, for your time today.
Everybody. Good to have so many questions and participation there. That's good.
It is. But like I say, it might be good to just hop on one of these sort of like a bit informally one time and just let people ask, like the doctor, when people go to the doctor and ask them questions. Ask Tony. Anyway.
Do some swatting up then.
Yeah, I don't think so. Anyway, have a great weekend, Tony. I'll see you soon.
Thanks, everybody.
Thank you.
Take care. Bye.
That's Tony Connor. He's very clever, isn't he? He knows his food safety stuff. So there's the certificate in the sidebar. So in an hour or so, I'll send an email with the recording, the slides, and I'll put the certificate in there. And then, if you have any questions, just let us know. So just give us an hour to get that out. You need to write your own name on the certificate. We can't do that for 1,700 people registered for today. So, I've enjoyed today. Thanks for joining in and all your questions and making it engaging. Sorry for those few technical problems early on. It's beyond our control. The recording will be perfect. It was perfectly fine for me. Lucky me. So enjoy the rest of your Friday. Have a great weekend. Stay safe and take care. And we'll see you next week. Bye-bye.